Hi, and welcome back to HeFPipe. And continuing where we left off on the pipeline, today's video involves running regression analyses on subsets of the full dataset. And what this allows users to do is run HFCs, or more generally regression analyses, on many different permutations of subsets of the data with ease. So for instance, let's say we want to know whether the strength of heterozygosity-fitness associations in our particular dataset increases when we look only at individuals who are stressed by a virus. In that case, I would start out here in terminal, where I'm asked whether I want to run regressions on certain individuals bearing certain trait values, and I would type yes. And then I'm provided with a list of trait names and some sample trait values for those traits. At this point, I type the trait and trait value, separated by a comma and no space, that together specify the subset of data that's desired. Now, it's possible to create subsets of data using permutations of traits and values across several different traits, or even within a single trait, provided that this trait has more than two values in the trait file, i.e. acceptor.csv in the example data. So for instance, I know that samples in the example dataset are either 0 for uninfected by virus 1, 1 for infected by virus 1, or NA to indicate missing data for virus 1. And I want to focus on infected samples, so I want to remove samples that have either 0 or NA as values for virus 1. So, whoops, and you'll see I had to make a really quick adjustment here. I was running the wrong pipeline. So anyway, in this case, I would type v1, comma, no space, 0, enter, v1, comma, no space, NA, enter. Now let's say I also want to remove missing samples or samples uninfected with v2. I would type v2, comma, 0, no space, enter, v2, comma, NA, no space, enter. And then I would type done because I'm done. The pipeline's prompts will then look exactly like those described in the full dataset regressions video, which is the video right before this, but the results will be saved in a new nested subdirectory called datasets inside the pipeline directory, and with another subdirectory inside datasets named after the trait-by-trait value combination or combinations that we just specified. So it's going to be named after the subset that we just made right here. Okay, so let's go find that directory. Inside pipeline, you'll see a new subdirectory called data subsets, and then a new directory even within that that's named after all of these constraints we just applied. Now inside this specific subdirectory, the pipeline generates a file containing only the individuals not bearing the trait values specified by you. And in this case, it's again named after the specifications we made here. So in this case, it's called v1 0, v1 NA, v2 0, v2 NA removed subset.csv. Let's take a look inside. And you'll see it looks exactly like mlh output.csv, except for it only contains the samples that are infected, in this case, both by v1 and v2, since those are the specifications we made. So the regressions we then generate in terminal here are going to be based on this data set alone. Now the new regression results are placed into the regressions directory as described in the previous video, and this regressions directory is nested within the subdirectory here. So here's the new regressions directory just for this particular data subset. So just as an example here, let's run a quick regression model here. Let's run it on queen weight initial, which if you remember from the previous video has a Gaussian distribution. Type queen weight initial as the response variable. Let's just use MLH as the predictor variable. That's it. And now type done. And you'll see those three files, again described in the previous video, are listed here. And you can see MLH is not a significant predictor of initial queen weight when we're focusing just on individuals infected by both virus 1 and virus 2. Now you can continue looping through this component by following prompts to do so for as many regression models as needed, and then for as many data subsets as needed. So let's say we don't want to run any more regressions for this particular data subset. We can say no, and it'll ask us whether we want to continue making a different subset. And we can say no here. And that's it for the data subset regression analyses. Of course, you could have said yes and carried on with other subset analyses and other regression models. Now next time,